Our final of the 3 chord theorems we've taken a look at is going to tell us 2 chords are congruent to each other if they're equidistant from the center of the circle. So using the diagram down here, let's kind of talk about the tick marks we're going to see. To be equidistant means, of course, the same distance. And so as far as tick marks go, I know that these two segments would have to be congruent to each other to show that the 2 chords in question, C, D, and AB, are the same distance from the center. However, not only do those have to be congruent, we also have to make sure we measure perpendicularly. So you'll see those right angle symbols as well. It's a fancy way of indicating that the chords are equidistant from the center. They're the same distance and it's perpendicular. What that tells me then is that these 2 chords are going to be congruent to each other, or vice versa. As we've talked about in the other videos, if you've watched those, I'm going to try to match my diagram up to this diagram to figure out what's congruent to what else. So let's take a look at a couple examples. First up, I can see that I'm given the 2 chords are congruent to each other, so I'm kind of working backwards, I guess, on this one. I see that both chords are labeled as 16, so I'm going to add tick marks for those. Because those 2 chords are congruent to each other, it means they must be equidistant from the center. And since I have measured perpendicularly, there's my right angle symbol, I know that those distances right there must be the same. So the whole idea behind many of these problems is just put the pieces equal to each other. Pretty much can't go wrong doing that for most of these problems. So 2x equals 5x minus 9. If I subtract 5x from both sides, I get negative 3x, but don't freak out that you have a negative, because I still have a negative 9 left over on the other side, and once I divide by negative 3, x comes out to be a positive number, positive 3. We wouldn't want distance to be negative, but it's not. Next example, last example, let's kind of do the same thing. I can see this time, and actually this time, notice, this is a really subtle trick, I think, on this problem. This piece right here, 3x plus 2, is not pointing to the entire chord. Instead, it's just pointing to this partial piece over here. There's half of it. So keep that in mind as we set this one up. I think this one's a bit tricky. I can see that even though there's no tick marks, these 2 pieces right there are congruent because they're both labeled 6. Because I also have the right angle symbol, it's telling me that these 2 chords are the same distance from the center of the circle. So I can again add those tick marks out here. So those 2 chords have to be congruent because of the same distance from the center. Remember how I said you can pretty much always set these things equal to each other and that's going to be fine? That's the case. However, this time it fails you. Setting 3x plus 2 equal to 22 is not going to work this time because, and this is where I said it's kind of tricky, the arrow is pointing just to this half of the segment. So it's not that it's equal to 22, the full segment, it's that it's equal to 11, half of the segment. So just watch out. I think that's kind of a cruel trick they play on you. But once we have that figured out, it's not hard to solve. I'm going to subtract 2 from both sides, so 3x equals 9. And once again, if I solve this, I find an answer of 3.